People all over the world were in shock and horror as they watched the events of Hurricane Katrina unfold in New Orleans in 2005, with the flood killing over 1,800 people and 130 more people reported missing. Some consider it one of the worst engineering disasters in the world, not just because of the death toll, but also because of the aftermath of the damages to the city as a whole. During the storm, 169 miles of the levees had been damaged, with 50 breaches which increased flooding by at least 300%. After the storm had passed, 400,000 people had ended up fleeing the city, and 125,000 more losing their jobs. Because the city is significantly below sea level, the water had risen to over 10 feet high, ultimately causing over $100 billion in damages.
In order to understand why the levees broke, we need to first go into the mindset and understand why the U.S. Army built the levees like they did. First of all, they were already in a tough spot. The areas that the levees surrounded used to be swampy forests with very soft and unsupportive grounds. Building a structure that was supposed to hold off tons of water in that situation has to be carefully built with that in mind. However, the U.S. Army did not take that into consideration. They did not come to the realization that a ground that soft would eventually have some give and ultimately sink if a heavy structure is lying on top of it. Second, because of their supposed restrictive budget, they only built the levees with low stress levels, designed to only withstand subpar Category 3 hurricanes. Little did they know that Hurricane Katrina was not that.
Hurricane Katrina was listed as a Category 5 in the Gulf of Mexico, but when it hit land, it quickly was reduced down to a Category 3 hurricane, still being geographically massive in size and strength, creating storm surges that were stronger than what the levees were built for. On the day that Hurricane Katrina hit, the storm surges were so strong that the design they had for the levees could not withstand the strain of the rising water. Combined with the already unstable and sunken ground and the lack of strength of the levees themselves, they began to tilt, causing the water to overflow on top of the walls and in between the levees and the ground it was built in.
Because the levees were not built for this type of storm in mind, the storm surges eventually pushed the wall over, toppling it and releasing tens of billions of gallons of water onto the unsuspecting city of New Orleans, killing over 1,800 people and covering around 80% of the city. So what could have been done differently in order to prevent a disaster like this from happening? A big reason why the levees were so weak was because of its erosion. The Army had built the levees out of materials such as concrete, sand, and other easily erodible materials. What they should have done was look for materials that do not get easily eroded. A new material that was founded in 2002 is ferroc. Ferroc is proven to be almost 5 times stronger than regular concrete.
One of the biggest issues with concrete is that it slowly erodes when it comes into contact with salt water. This new material, ferroc, does not. It actually gets stronger when it comes into contact with salt water. Being founded in 2002 should have given the city of New Orleans and the U.S. Army enough time to at least rebuild and strengthen the critical points of the levees that were in most danger. In this graph, we can see the concrete's limitations on stress and strain. Since ferroc is proven to be 5 times stronger than concrete, we can determine just how its numbers line up to the concrete's by looking at this graph.
A mistake that they could have fixed in the beginning is using clay instead of sand and seashells. Heated and hardened clay is very hard and much more resilient and resistant to erosion, whereas sand is very loose and can easily be washed away. If the Army had realized that using erodible materials such as sand and seashells would lead to the demise of the city, maybe they would have chosen different materials to build the levees out of. As you can see by the graphs I have displayed, it is clear that hardened clay can take quite a significantly more amount of stress than sand, as clay doesn't start giving until it has reached almost 3 megapascals of normal stress, whereas sand gives away in the kilopascals range. Since Katrina hit in 2005, the city of New Orleans has rebuilt and reinforced the levees. However, they still use a lot of materials that would be disastrous if any storm produced storm surges as big as Katrina. Since then, they have strengthened their levee walls by using a mixture of earthen and concrete materials as well as improved their water pumps.